Number 43, our directions right here are to complete the square and find the minimum or maximum value of the quadratic function. Hopefully you guys remember that a quadratic function is either a parabola that opens up or a parabola that opens down. It's one or the other. And the direction that it opens determines whether it has a max or a min. An upward opening parabola has a minimum value, but no maximum, because it keeps rising on both sides. And a downward opening parabola does the opposite. It has a maximum, but no minimums, because it goes down on both sides. So I'm hoping you guys could tell me already that this particular quadratic equation, here's your x squared term, which has a negative leading coefficient, is going to be a downward opening parabola, not an upward opening parabola. And that means that this problem, or this particular quadratic function, is going to have a maximum, but not a minimum. And where is that maximum or minimum always going to occur? Right here at the vertex. Now, what the directions didn't really explain is this. If you want to find the vertex of a parabola, you could do the formula, don't write this down, x equals negative b over 2a, and figure it out from there, and that certainly wouldn't be wrong, but the directions here are asking you to do that in a different way. They want you to complete the square, to get a little practice at that. And completing the square is a way, in a weird way, that you can get an equation, a quadratic, from standard form into vertex form. So let's talk about how we're going to do this. Now, right off the bat, guys, if the directions didn't tell me to, I would tell you this is not a good candidate here to use completing the square. For completing the square, the two things we really like to see, first of all, we want a to equal 1, and second of all, no, that's a 2, we want b to be an even number. Well, in this problem, a is negative 12. I don't like that. B is even, but that negative 12 is a bit of an issue. So I'm going to deal with that. I'm going to factor out a negative 12. And then I'm going to switch my order now so things are a little bit more like I like them. When I divide out the negative 12 from this term, I'm just going to get an x squared. And now I'm taking the second term, which has a coefficient of 4, and dividing out this negative 12. 4 divided by negative 12 is a negative 1/3 x. And I'm going to leave a little room right there before I close that parenthesis. So the why I did that might not be clear just yet, but hopefully you guys are comfortable with the ability to do that. The fact that if I were to distribute this negative 12 back in there, I would end up right back where I started, and that should at least tell you that it's legal. It's okay to do what I just did. Now the goal here, now we'll get to the why, the goal of completing the square is to create a perfect square trinomial inside this set of parentheses right here. How do we do that? Well, you'll notice a is now equal to 1, so I like that. The next thing we're going to do is take b, cut it in half, and square it. So, not a whole lot of fun. B here is negative 1/3. We're going to take half of negative 1/3, so write this down if you need to, but it's a negative 1/3, and taking half of it would just be multiplying it by 1/2. That's going to get you negative 1/6. So that's half of b. We then square that, and that negative 1/6 squared is going to be a positive 1/36, and I'm going to add that right here. Plus 1/36. Now that's what I did in order to create a perfect square trinomial there in the parentheses. However, this should make your mathematical spidey sense tingle just a little bit, and you should be saying, whoa, 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 you can't just add that 1/36 anytime you want to. And you're right about that. I can do it as long as I counteract that in some way. So let's talk about how it is that we're going to do that. And when we're dealing with quadratic functions, which have a y over here or an f of x, we do this a little bit differently than we would if we were solving a quadratic equation. Now, the first thing we need to realize, this is not a 1/36. It looks like it, but this negative 12 out in front actually needs to get distributed inside to this trinomial. So what I actually did is I added a 1/36 that needs to be multiplied by negative 12. Now, negative 12 times 1/36 is going to end up equaling a negative 1/3. So even though it looks like I added 1/36, what I really did was subtracted 1/3. Now, if you have subtracted a 1/3 from the right side of your equation, the tempting thing to do would be to do a minus 1/3 over here on the left side. And that's not wrong. You certainly could do that. But again, we're trying to keep the y by itself because we're dealing with a function. So what I'm going to do instead of subtracting 1/3 from the left is add a 1/3 at the very end of the right side. So one more time, what we did because of this and this, that means that we actually subtracted 1/3 on the right, which I've now counteracted by adding a 1/3 at the end. So hopefully now you're feeling like, okay, we did some stuff, but we counteracted that stuff, and everything is still in balance, like you're dealing with stoichiometry in a chemistry equation. Okay. So that's where we're at. That's the end of this second line. Let's keep going now. Y is equal to, that -12 just tags along for the ride, and in parentheses now, we formed a perfect square trinomial, which means it's going to factor into a binomial squared. And hopefully you can do this in one step without having to do this and then think about it. The square root of x squared is x. That goes right here. The square root of 1/36 is 1/6. And whatever sign you're dealing with right here, that's the sign that comes down here. So x squared minus 1/3 x plus 1/36 factors into x minus 1/6 quantity squared. Feel free to multiply that out and test that if you want. Nobody ever takes me up on that offer. And we still have a plus 1/3 at the end of all that. And this is something that I really wished you guys learned better and embraced a little more over the last 2 years, but people tend to fight it for some reason, even though it's easier. This equation right here now is in what we call vertex form. And if you have an equation in vertex form, it's pretty quick and easy to graph. The vertex then, from vertex form, is the same h and k that you guys I think are used to dealing with over the last couple of years. Your h value is what's being subtracted from x right here, so that's going to be a positive 1/6. The k value is what's being added at the end. That's a positive 1/3. So remember, guys, h kind of changes sign. I know this looks like a negative 1/6, but h is actually positive 1/6. K, though, is straightforward, and it does not change sign. So this is what we have here for our vertex, 1/6, comma 1/3. And back to the actual question in the problem, find the minimum or maximum value of the quadratic function. Because this is a downward opening parabola, we know that it has a maximum. And the maximum value, now remember, when they say that, they mean the maximum y value of a function like this, a parabola that opens down, is the y value of its vertex, which is going to be 1/3. So the directions to the problem said complete the square. All right, and that's what it would look like when I did that. And then it said find the minimum or maximum. So kind of a two-part answer here. There's the answer to the first part, and here's the answer to the second part. And that is how you complete the square on something that was in standard form and how you handle a problem like 43.